Next, I move on to visualization. So I import, so I begin by importing matplotlib and then Seaborn, and then I begin by basically using Seaborn and basically making a counterplot to see the distribution of all the different species of iris flowers. As we can see, as from previously before, they all have 50, so each one has 50 in the data set, so that's cool. Then I move on to the correlation matrix. So plot.fig, fig size equals 10 and A. This basically creates a new dimension with 10 inches by width and 8 by height. Numeric data is equal to iris data. With this basically filters out the iris data frame to only keep the columns with like the numeric data types. And then as correlation, it's a correlation matrix over here, can only be calculated between like numeric features. So yeah. Then I move on to correlation matrix is equal to numeric data correlation. Basically, what this does is it calculates the Poisson correlation coefficient between every pair of the numeric like column in the data set. And then I will use CMap to basically use heat map to like color them out. Then I give a title and then I plot the thing over here. So from the diagram, we can tell that the redder it is, the higher correlation it has. For example, petal length with the pair of petal width has a high correlation as compared to the sepal width with its pair with petal width. So yeah. Then we move on to the feature distribution across the species. I basically began by plotting the figure, which is like a 14 inches by width and then 18 by height, 10 by height, I meant. Then we move on to iris. Melt is equal to PD. Now melt iris diffa in ID vars is then I put species, value vars is equal to spatial length, spatial width, petal length, and petal width. Var name is equal to feature and the value name is equal to value. So basically the melt function, basically we can convert the data from like a from a from a wide format to like a long format, and then the ID that vars is equal to species. What this does is it keeps the species columns as identifier, and then the vars is to basically what this does is specifies like four measurements for it to be melted into the rows, which are the spatial length, spatial width, the petal length, and the petal width. The var name equals feature. What this does is basically names the new column containing the feature's names as feature itself. Value name is equal to value. It names a new column containing the measurements as value. Basically, the melted format basically allows us to basically easily plot like multiple features side by side without doing this, we would probably need to like separate we would probably need to separate each plot separately for each feature. So yeah. Then I created a box plot by using Seaborn, and then afterwards I titled it, I labeled like the X variables, the Y variables, put on the grid, tighten it up, and I basically plotted it. So from this feature by species graph, we can basically tell that Iris virginicana has the highest range, has the greatest range in the length, then followed by the Iris vericula, and then the Iris ceatoso. Then the spatial width over here is followed up by like the Iris ceatoso having the highest range, then followed up by the Iris vericula, and then followed up by the Iris virginicana with outliers over here, and then followed up by the petal length, which is so the Iris vericana has the highest range, then the Iris vericula with the outlier over here, then followed up by the lowest range in this case, which would be Iris centona, with like few outliers over there. Then the next data column is like the petal width. So the Iris vericana has the highest range, followed up by the Iris vericula and the Iris Satora. So basically, we can tell that the Iris Satora is like different from like the other two species, especially if you're using like petal measurements over here, as it's basically kind of like an outlier as compared to these two. So however, Iris vericana and Iris vericula, they're very similar, so like So finding the difference between them will be more difficult, as it shows some overlap in like some measurements, like iris length, iris width, and like the petal length and petal width. But so yeah. Um, so from this graph, the best feature for classification for us would be the petal length and the petal width, as they're the most distinct feature, which will likely be important variables in our which are going to be important variables in our classification model.